Okay, so back to the second point again. I was just saying that the gradient has to be positive because they say m is an element of r plus. And I'm trying to find the x-axis intercept, which occurs when y equals 0. Yeah? So that's all I'm going to do. I'm going to solve the problem just as you would. Let y equal to 0. And you got mx plus 2. Solve for x. And you get what we call a literal equation. This is a literal equation because it doesn't give you an answer, but you can interpret from it. You can interpret your answers from this being x equals -2 on m, and m is positive. Meaning that your x-intercepts are always going to be negative. That's what it's implying. If you had to visualize this, if m was always going to be, if m was always going to be positive, then you're always going to have -2 over a positive number. So logically, your x-intercept is always negative. Now logically, this makes sense. Because if you were to visualize this, y-intercept at 2, and your gradient is always positive, no matter what you do, your line is always going to intersect a negative. Your x-intercept has to be negative. It makes sense. How could you have crossing 2 and have a positive gradient and have a positive x-intercept? It just doesn't make sense. Okay, so in terms of interpretation, what I'm teaching you there is, yes, you are doing the algebra, simple algebra, but interpret it. What does it mean? How you're reading it? That's important. Okay, so now I know, okay, I've got this equation, it's -2 on m. Then the next part, you know, that I've answered the question, x-intercept occurs at -2 on m, which I know it's always going to be negative. Next question, for which values of m is the x-axis intercept less than -2? So now you found the x-intercept. The x-intercept is -2 on m. You're asking now, when will this x-intercept will be less than -2? It sounds hard, but it's not, because all you're saying is graphically, you're just saying crosses through 2, and when, for what values of m will you make sure you have x-intercepts less than -2? So it could be like this. It could be like that. The question is, how do you find that? Well, answer the question as it says. It says x-intercept, I want it less than -2. So I type it in. I actually say the same thing. I say, all right, for it to be less than -2, this is my x-intercept. And I want it less than -2. So I wrote that, less than -2. So if I solve for that, that will give you times m on both sides, and you get -2 is less than -2m. And therefore, dividing both sides by -2, which is -2 and -2 is 1, which is a fair call, but don't forget that every time you divide or multiply by a negative, the sign switches. Okay, and so therefore, if you chose m less than 1, it's all good. You'll always get anything that's going to be less than -2. Okay, so I'm just answering the question based on what the question says. So I know it sounds difficult, but you see, in terms of the interpretation, I did exactly what it told me. X-intercept less than -2, and I solved. Okay. Now find the inverse function. That just goes back to your chapter 1. Switch the x and y's. So I switch the x and y's, and I solve for it, and I write out my inverse function. But keep in mind, when they ask you to find the inverse function, when it comes to an exam, especially in the exam 1, state the domain. Okay, it's not sufficient to, and don't write it in terms of y. Don't write it like y equals to x minus 2 on m. That is not good. Okay, unless the function was in terms of y, then maybe you can say the inverse function y -1. Otherwise, if it's in terms of f of x as it has done, then you should write it as inverse, f -1 inverse. Okay, but as a habit, I want you to start writing your domain and range. Every time they ask for a function and you have to define it, write your domain as your priority. Okay, not necessarily your range, but definitely your domain. Okay, because the domain dictates your range. Right? So here I just went where range of f is domain of inverse. So they've already given me the domain, so I know the range, and therefore I can work out the domain of the inverse. Okay? And then finally, perpendicular just goes back to your, back into year 9 mathematics, perpendicular lines. Gradient 1 times gradient 2 is -1. And since we know that looking at this equation of my inverse right over here, This is my equation of the inverse. The gradient currently is 1 on m. So that means 1 on m multiplied to something has to equal to -1. Okay? And I think I made a mistake. That should be -m to give you that -1. Okay, and therefore the only mistake I would have made is that -m there, but the +2 should be the same. And the reason why I know it's +2 because it says it crosses through 0.02. Okay? And because it crosses through 0.02, you know that the one interceptor has to go 2. So you see, the questions aren't hard. It's more like it's all in that interpretation. You would have easily done these type of questions in your SAC, and that's why I'm saying this exercise is not hard. You would have already done it, but I'd rather you get the concept out of it. And the concept is: can you work with literal equations? Can you interpret from them? Are you careful with the domain and restrictions? Are you able to picture what it may look like graphically to answer the question? That is the skill that you need to take out from this exercise, not necessarily how do I do it. Okay, so the how should be easy. The why is what I want you to take out. Okay. Now, this is another same thing. I just thought I'd bring this back in terms of matrix transformations in case you know that sort of faded out of your memory already. I thought this question might have been nice to work with. And again, it's in your textbook. So in this question here, they tell you that you've got a matrix equation, which is this transformation here, and they want you to find x and y in terms of x dash, y dash. All they're really saying is read this transformation and rewrite that in terms of x and y. So if I had to rewrite it for you, I could say, well, if I expand it using matrix multiplication, 5 times x, 0 times y, and you get 5x plus 5 equals x dash for the first line. Same thing with the next one, 0 times x is 0, k times y, which is ky, and you've got plus 2 equals to y dash. Okay, so we've got two linear equations. It's right there. And all they're asking you to do is rewrite this transformation in terms of x and y. So that's all I did. I just rewrote it, and rearranging it gives you the following. Okay? An answer to the question, find the image. So from here, I want you to understand that x and y coordinates has been changed to 5x plus 5. If this is something that you relate to better, then write it like that. Okay, let's just do transformation. You're saying substitute x, y, and you times 5 to the x plus 5, and then k times y plus 2. That gives you a new image. That's what image is. That's your final product, right? And the question says find the image of the curve if you have y equals 1 on x. Well, we already found out what x is, we found out what y is, and the equation is y equals 1 on x. So all you're doing is just you're replacing those x and y's to find your new equation. That's what Transformations Chapter 3 was all about. Yeah? So that's all I'm going to do. I'm going to say resubstitute your answer from A, and you put it all together, and you get your new transformation equation. Yeah? Now the last question. Find the value of k if the image passes through the origin. Origin is when the coordinates are 0, 0. So if I had to look at it, 0, 0. I already got the image equation, which was given previously. We found out it was this. So if I had to work out for k, it literally just meant sub x and y coordinate and then find k. So in exercise 7e, as you can see, is nothing difficult. It's the same thing over and over. It's just, can you interpret everything you've done? Matrix transformation, functions, domain, range. If you can do all that and interpret and graph it and find the restrictions, that's 7e, which you don't really have to do. Okay, so if you understood that, fantastic. That was for your SAC. If you did it, if you didn't understand your SAC, this might be worthwhile doing again. Okay, because it's an abstract sort of process. It's a step for you to learn to interpret your equations rather than going, okay, if I get this question, I'm going to do it this way. It's not about that. Okay, mathematics is meant, or methods anyway, it's about you analyzing the situation and then answering it appropriately. Okay, it's not meant to be A, B, C, D. It's meant to be look at the question, read what are your restrictions, and answer appropriately. Okay, now, having said that, let's look at this question for your exam. I thought this was a nice one because it goes back to, again, your understanding of matrices and in an abstract form. Now, this one is the one that was 21% of students who got this correct for that year, so 2005. And I think it's a very easy question. I did it in less than 10 seconds by looking at it. So You don't need a calculator, you don't need anything, you don't have to do matrix multiplication and whatnot. You can look at this, and if you understand the question, you know what the answer is straight off the bat. Okay, so I'm going to give you maximum 2 minutes to do this question and see if 21% of us are going to be the same as them in 2005, or have we improved since then and learned transformations better. Okay, here we go. This is now 9:59, so when it's 10:01, see if we can answer this question. One more minute. And it's 10:01. Okay, let's see. Hands up if you got your answer as A. Okay, 1 out of 60. Hands up if you got your answer as B. 0. Hands up if you got your answer C. 0 as well. Hands up if you got your answers D. A few members. Okay, we're all watching everyone else. That's good. Yes, go with the majority. That's the key. Okay. And finally, obviously, I'm assuming all of you got E. Hands up if you got E. Okay, we've got a nice few. That's about a third. It's about a third. That's not bad. That's about a third. Okay, let's have a look. Which is the answer? Start off. The very first key information was it said infinitely many solutions. Now I said that infinitely many solutions means that it has to be the same line. That's the very first step. You had to know that these two linear equations, because that's got a y variable and x variable, it's a linear equation. And it has to be exactly the same line for you to have infinitely many solutions. Otherwise, you would have one. You know, if you have two lines, it crosses once, or it's parallel, it doesn't cross at all, or it's exactly the same, hence you cross infinitely, right? So, if you understood that it has to cross infinitely, then what you're saying is you're saying these two lines, they have to occur, or they have to be exactly the same lines. Well, right now, see AY and CY, B and D, we want these to be equal. But the problem is the scale's different. This one is X and this is 2X. So what I want to do is I want to say, what if I just multiply the first equation by 2? This gives me the new equation, which I'm just saying, this becomes this. Why did I multiply by 2? Because I wanted these two to be equivalent first. See, I don't know what A is and I don't know what C is, but what I do know is if I multiply the equation by 2, I will have 2x, and in comparison, I will now have cy plus d, and therefore, if they're both exactly the same equation, I can now say 2x equals to 2x, and I can then say 2a must equal to c, and therefore I can say 2b equals d by comparison. And I'm comparing the values of a, b, c, and d. You see, it would have been much easier if I'd given you something like this. If I said 3x plus 2y equals 6, and then I said this is 4y plus AX equals to 12. You see, if I had done that for you, every one of you would be able to answer that question. You see, you would have been like, oh yeah, double 6 is 12, double 2 is 4, so that means A has to be 6. You see, why is it that you can do that almost instantaneously, and you found the pattern straight off, you knew what it had to be, but as soon as I put literal equations, which is just change it all to letters, then it becomes a problem. You see, I changed it all to letters except for the 2. It's the same concept. And it's the question of, that's what I'm saying, exercise 7E, the literal equations part, is about you being able to imagine that these letters are numbers and interpret that. Because if the first one was easy, then the question is why they're both different. It's not meant to be different. They're exactly the same question, and it's the same level of questioning. It's the question of abstract. It's how abstract it is for you to interpret. And that's why this question was difficult for a lot of students, because they would have tried all the techniques you would have learned, matrices, try to solve it infinitely, many solutions, but really, it was testing the one concept. Did you know? Okay. So that was a nice question. That was, and this was just the results on the bottom. So actually, that's 38. There was another one. Sorry, that's 38%. There's another one that's 21%, which you're going to do soon. That's 38%, and not many students really use that idea. So this was 2005. It was a nice one. Let's try this one now. Actually, did we do this? No, that was on your sheet. That was on your sheet. Oh, well, that was just recapping on yesterday's work about function notation. So if you haven't tried that, have a look at this PowerPoint. I've described the answers for it. The answer was C, and just less than 50% of students got that correct, which I find very bizarre, because you can substitute and use. So function notation, learn to use that. If you didn't practice what I said yesterday, look back at this PowerPoint, and I've described how to get the answer. Okay? Now, let's go into the one that was 21%. This one. And I have a feeling because 2005, transformations wasn't really taught well back then, and the understanding for it was very difficult along with matrices. Matrices would have been new in that year, and so this would have been a little challenging for students. So it's probably why they got 21%. But I reckon by 2016, we've improved our transformations in terms of teaching you guys. So I reckon we'll get more than 21% this time. Okay, so have a go at this question. I'll give you 2 minutes as well. So it's 10:06, plus 2 will be 10:08. It's technically a chapter 2 question. You would have done this over and over. There's one small thing that makes a mistake that a lot of students make. That's why they don't get the right answer. One minute left. All right, time's up. Let's check. 21% of us, whether we're going to get it right or not. Okay, let's go. A. Hands up if you got your answers A. No? Okay. Hands up if you got your answers B. Hands up if your answer was C. That's good. So far, we're sitting on C, D, or E. Now, I would imagine that most of the majority is either D or E. Hands up if you got your answers D. Ooh. Hands up if you got your answers E. And yeah, it's more, that's about I reckon that's close, more than a 21%, but less than 30%. And the interesting, I'm assuming the rest is, I have no idea, okay? Now, for you who got D and E, that's a good approach, meaning that you were using the right technique. For C, I'd say that you misinterpreted the question. For A and B, you should have known that that was totally out of the answer. Okay, now, let's have a look at how we do this. And the only mistake, I'll show you where the common mistake is, which is why people get the answers D. Okay? Let's read the transformation. If we were to read it first, and this is the key part that a lot of students make a mistake, is right here. See, my transformation, when I read it, it means left by 2, and then dilate by a factor of half. So meaning the sequence is left by 2 first, then dilate by a factor of half. A lot of students will write it as the other way around, where they write multiply by a factor of half first, then, whoops, left by 2. Okay, that should be left by 2. So the question is why is there that mistake? And the mistake comes from the idea that you forget there are brackets. And remember, brackets comes first. Bud mouse brackets comes first. So you're saying add those 2 first, then multiply it to the matrix, and that's where the mistake generally comes in. So you multiply, you add those 2 together, and then you multiply. Technically, that's what you're saying. You're saying x minus 2, then multiply by 0.5. Okay? And that's what I'm sort of showing here. I'm just saying add these 2 together, which is x minus 2, and then you're multiplying the factors by, so x times that and 0 times y. So that's why it becomes 0.5. Okay. Okay, so alternatively, another way of looking at it, if you're used to looking at this form, so the last question I did in this slide before was about matrices. You can either write in matrix form, or you can write it as your transformation form, whichever you like, okay, but they mean the same thing. Then all you have to do from here was solve. So you know that this is your x dash, that's your y dash. If I had to solve it or expand it, that gives you your times 2. Technically, this 0.5 is the same thing as writing half. So times 2 on both sides, and then add 2 on both sides. That's how I get that. And then I apply y equals y dash because that hasn't changed. So that means in my equation y equals x cubed, if I put it in, I get 2x plus 2 cubed, which actually gives you the answer as E. Okay? And the only reason why you would have got D is because you made that initial mistake of doing the multiplication first before the addition. So that means that you were on the right thinking. It's just that you read the sequence wrong. Okay, but that was the only reason why it was hard. So that's the only part that I think there would have been a mistake, but that's a chapter 2 problem that you would have done over and over in your exercises. Okay, and I want you to just take that in, and that was 2005. We should have improved on that. This was the year, that's the 21%. 1% of the cohort left it blank because they couldn't answer it. And their technique is exactly the same way as I've taken it. So they've either taken it through reading the transformation, or they did the matrix, which is what I did. I did the matrix and then I solved it. Okay, but that's it. So those 3 questions, I'm trying to get you to think in terms of your sort of interpretation. Is everything you've done, chapter 1, 2, 3, 7, is exactly the same. It's over and over and over. All those sheets that I'm giving out are questions on functions that you can do now. Okay? So you got about 10 minutes left. Please have a go at these questions. Now, specifically, the first 4 you should be able to get right. Okay, the first 4 you should be able to get right. It's the last one that I want to have a look at the end. The last 3 minutes, I want to have a look if you all know how to do that type of question. Question 8 of 2008. It's a typical question to come up. Okay? So I want to know that. Give you 7 minutes, and then we'll go through the answer to question 8, 2008. Okay. Yes, you may.